So today we will go with array operations from data structures. So you people already know what is an array. Array is a collection of items of same data type. So when you have certain elements in an array, for example, I have an array like this. I have an array. I have inserted certain items into an array. Always, indexing always start from 0, and I have inserted 1, 10, 20, 30, 40, 50, 60. This is an array where you consider certain items are inserted into an array. You people already know this operation of insertion of an items into an array, that is initialization of an array operations, which I have done in the previous slides. You can check that. Arrays review of data structures. So how to insert an array using for statement. I will insert certain elements into an array using scanf, and if you want you can use printf to print the items. Now I can perform certain operations on this array. Now look here, I have inserted already 20, 10, 20, 30, 40, 50. I need to traverse, that is I need to go from each and every item one after the other. That is I visit 10, then I visit 20, from 20 I need to go to 30, then 40, then 50, then 60. That is I need to traverse. I need to go from each of the element at a time, and after traversing I need to print them on the screen. That is one operation, that is 10. I'll traverse, I'll print it on a screen. 20, I'll traverse, print it on a screen. 30, I will print it. 40, 50, 60. Like this, one operation I'm performing on the array. This is known as traversal. I need to visit each and every item at least once. Only once I visit, at least once I visit, and after visiting, I need to print it on the screen. That is one operation. Now, this is an example of an array. I have already certain elements into an array. That is, I have 10, 20, 30, 40, 50, 60. I need to insert one more item into an array. For example, here somewhere, this is the position, and always look to that position is different from indexing. For example, this is first position, this is second position, third, fourth, fifth, and sixth position. Positions will start from 1. This you people have to remember. And indexing will start from 0. Indexing is nothing but position minus 1. Position is different from indexing. Okay, so at the second position you have 20. There is 20 over here, but I don't want 20. I want to shift this. I want to shift all the elements, that is 10. I need to shift 20, 30, 40, 50 and 60, and I need to insert a new element here. In the second position, I need to insert a new element. Okay, for example, I insert 70 over here. This is insertion operation. Okay, this is insertion. I have inserted a new element somewhere in middle of an array, that is insertion. Now after inserting, I do certain operations. I don't want certain element in the middle of an array. I want to delete that item in an array. For example, this is an array, whichever you have. Like this you have, this is an array. And here in this array somewhere I need to delete this 40. I don't want this. I need to delete this 40. After deleting, what you have to do? You have to delete 10, 70, 20, 30. I need to delete an item, and this item will be deleted, and you have to bring them back. These numbers have to be brought back. Okay, move them back. So this deleting an item in the middle of an array is known as deletion. So these are the very important operations that we perform on array: traversal, insertion, deletion. And after performing such these basic operations, I need to search an array. I can sort an array. What is searching? Searching is nothing but, for example, this is an array. I need to search. I'll give an element known as key element. I'll take element as a 30. And this 30 I have to search in this array whether 30 is there in the array or not. Yes, here, look here. But when searching, what I have to do, I have to start from the beginning. I have to go 10, compare, no, 10, compare with 70, no, compare with 30, 20, no, compare with 30, yes. Here somewhere this element is at the position 4. That is known as searching. Finding an element in particular indexing or particular positioning is known as searching. Update, that is update an element at a given index is known as updation. And sorting. For example, look here, these elements are in not a sorted order. Some is in high, 10 is low, 70 is greater, 20 is low. I need to arrange them in a proper order, either in increasing order or either in descending order. Arranging the elements properly is known as sorting. So those are the important basic operations we perform in this array, and very important basic operations which we have are traverse, insertion, deletion, searching and sorting. Searching, especially we will go with linear search and binary search. Sorting, we can go with insertion, sort. So these are the various important array operations which we have in our data structures. First, we will go with traverse. I told you already, I have already inserted an item into an array. I need to travel each and every element at least once. That is known as traverse. Traverse is nothing but visiting an item at least once. Visiting item at least once. That is known as traversal. Okay, so in order to write this coding, that is, I have a particular element over here. I have inserted an item into an array. To insert an item into an array, you can use for statement for I equals to 0, I less than n, I plus plus. Then you can write scanf, percentage d, and a of I. This is an array I have declared, and like this I am writing, and I will insert a value into an array. For example, I insert 10, 20, 30, 40, 50. I'll insert this into an array. This is the basic operation for arrays. This is main important insertion or basic important, the values which we put into an array is in this. Now I need to traverse this. So to traverse, that is, I will take this as indexing 0, 1, 2, 3, 4. That is traversing, or it is nothing but visiting. Visiting the item and printing them. Visiting item and printing is known as traversal. Now I have put the values into an array. I have to visit them and I have to print it on the screen. So for that, what we have to do, I have to visit, I have to go to indexing 0, then I have to print it on the screen 10. I have to increment the, for example, I'll take this as I. I is 0, 10. Then I have to increment the value of I by 1. I will come here, I will visit 20, I will print it on the screen. Then increment the value of I by 1, I will come here, then visit 30, print it on a screen. Then increment the value of I, visit 40, print it on the screen. Then increment the value of I, visit 50, print it on the screen. Then if you increment the value of I, we should end the for statement here only, so that even though increment value of I, you will not get a value. So that for that condition, what we do, I will take it as I is less than n. This is n, so I will take it as I less than. I'll give the condition this in a for statement, so that I will stop the iteration here itself. So for that, I have to write a simple program. Now look here, I have written a program using functions, printing all the elements in an array one by one. I'll write it as void display. If you want, you can write functions. If you don't want, you can remove. Without functions, you can write. So int I am declaring an I, then array elements are. Now I need to print it. I have already put the values into an array. Now I have to print it on the screen. So I'll just write a printf statement. The elements are, the array elements are. I need to print them on the screen. So look here, I'll write a for statement. For I equals to 0, I'll start with indexing 0 and I is less than n till n. That is till, for example, I have taken 1, 2, 3, 4, 5. I is equals to 4. I'll start from 0. I is less than 5 till here. That is I less than 5. Only 5 elements I can print it on a screen. So for that purpose, I have to stop the iteration here. I'll write I is less than n. And then I need on incrementing, right? Once I start visiting 10, I have to increment the value of I. This is an iterative process. I need to keep on doing this. So I have to increment I plus plus. Now look here, I have to print it on the screen. Percentage D, A of I. Whatever the values there in the array, you have to print it on a screen. Now first we will go with the first for statement. We will just see this. Then we will check how we will print it on the screen. Now look here, for I equals to 0, I less than n, I plus plus. Now I is equals to 0. Yes, the condition is to I is 0. 0 is less than what? N is nothing but 5. I have given 5. Yes, the condition is true. 0 is true. So now print A of I. A of 0. So your people already know this indexing. This is A of 0, this is A of 1, this is A of 2. Like this, we will be indexing on the array. So now print A of 0. A of 0 is nothing but 10. So 10, look here, 10 will be printed on the screen like this. Now I need to increment. I need to go to this indexing. So increment the value of I by 1. So I plus plus. Now increment the value of I plus plus I is 1. 1 is less than 5. Yes, the condition is true. So now print the value of A of 1. What is A of 1? 20. So 20 is printed. Now increment the value of I by 1. I is 2. So 2 is less than 5. Yes, the condition is true. So print 30. Then again increment value of I is 3. Yes, print 40. Then 4. 4 is less than 5. Yes, print 50. Then again increment the value of I by 1. 5 is less than 5. Now look here. This condition will not satisfy. Once this condition becomes false, come out of the for statement and come out of this function. So finally, I have printed all the elements on the screen. This is known as traverse. Visiting each item at least once is known as traverse. Okay, this is one important function. Now we will go with the insertion. Now, as I told you, I have certain elements in an array. I need to insert a new element in certain specific position in an array. I need to insert a new element into a specific position to an array. It can be any position. It can be in the middle of an array. It can be in the middle. So to do that, I am using certain operation that is known as insertion operation. Insert operation is to insert one or more data elements into an array. Based on the requirement, new element can be added at the beginning, either at the end or in the middle of the indexing. To add an element in the beginning is very easy. To add an element in the end is also very easy. But to insert an element in the middle is little bit trickier thing. Okay, so now I have an array. Now I will take an array, for example, I will take an array. So this is for insertion. I'll take an array 6, 2, 0, 4, 5, and this is indexing. Okay, this is indexing 0, 1, 2, 3, 4. Now, for example, this position. So position is now for me it is 3. So always remember position will be starting from 1, 1, 2, 3. Indexing will start from 0. So indexing is position minus 1. Now what I have to do? I have to insert a new element here somewhere. I want to insert a new element here in the third position. I need to insert a new element here. Insert a new element here. So what is the basic operation? So I just insert over here. For example, I want to insert a new element 10. I will insert 10 here. So I'll insert 6, 2, 10, 4, 5. I'll insert a new element somewhere here, that is indexing A of 2. I will insert 10. So now I have inserted 10. It is okay for me. I will insert somewhere A of I equals to 10. I have put some. But what about this value? What about 0? 0 is gone for me. So you have to think this in your very important thing while inserting an array elements. First, what you have to do is you have to shift the values particularly from particular indexing to the next indexing or to the next position. Now look here, I need to shift 5 here, then 4 here, 0 here. I need to shift the values from particular position to the next position. This is very important. Shift the values to next position so that when you shift the value, now look here, 5 is shifted here, 4 will be shifted here, 0 is shifted here, and here there is no element. This element is free for me now. So now here I can insert a new element. Once you shift the items, then only you can insert a new element to get that item proper. Okay, so this is the basic logic of insertion operation. So now what do you do? Look here, I need to shift the position. I need to shift the elements into the new position, then I have to insert. So what will be the logic of that? So what will be the for statement? Always see to that, look here, this is what, for example, 1, 2, 3, 4, 5, I have taken L elements, n is equals to 5. So always start a for statement with n minus 1 because n minus 1, I have to start here from here. Look, this is n value, that is n minus 1 is nothing but this last indexing. So start with last indexing because I have to shift this element 5. I shifted this to here. So start with n minus 1. And what will be the condition? I is greater than or equals to position minus 1. This is very, very important. Why? Because look here, for example, position is 3, indexing is 2. Look here, this is what I will take here. Position minus 1. That is nothing but this. For example, I have taken a new element where I need to insert a second indexing, that is position minus 1, 3 minus 1. If it is greater than that, you have to insert. If it is less than that, you can stop it. And now what you have to do, look here, this is what. Now I am shifting here. For example, now I am shifting this. First is shifting, then we will go with insertion. Now I have to shift 5, I have to shift 4, I have to 0. Now after shifting, what I have to do, I have to shift 5, I'll shift 5 here. What I have to do, I have decrement the value of 5. So I is decremented by 1. Keep on decrementing till you get a free value over here. So that is mentioned over here in this statement. So now after decrementing, for example, now I write a full for statement here. For I equals to n minus 1, I is greater than or equals to position minus 1, I minus minus. Okay. Now I equals to n minus 1. For example, I will take it as n equals to 5. So I will start with n minus 1. I equals to 5 minus 1. I is equals to 4. Okay. So I need to enter the position also where I need to free the space. For example, I'll write position as 3. Position is equals to 3. So now I is equals to 4. 4 is greater than or equals to position 3 minus 1. The condition is true. Why? Because till here only I have to do. After this, I don't need to do. Only till here I need to free the space. So for this condition, I'll take this. Now 4 is greater than or equals to 3 minus 1. Yes, the condition is true. Now what happens? You need to shift the value. Now look here. A of I plus 1. This new value, this will become this. That is A of I plus 1 is equals to A of I. What is that A of I? A of I plus 1 is A of 5 is equals to A of 4. Now look here, A of 5. Now again I have taken a new value here. I am putting a new value, that is A of 5. That is A of 5 is equals to A of 4. Now whatever the value of A of 4 will come to A of 5. That is A of 5 is now 5. I have to put a new element comma 5. Like this you need to do this repeatedly again and again. Now increment the value of I by 1 because now look here, I have shifted this. I have shifted 5 to 5 here. I have shifted this. Now I have to shift 4. 4 from here I need to shift. So decrement the value of I by 1. So I minus minus, that is I is equals to 4. 4 minus minus, that is equals to 3. Now I is equals to 3. So 3 is greater than or equals to, what is the position? Still position is 2 itself because still there I have to do. So now the condition is true. So now A of I, 3 plus 1 is equals to A of 3. That is A of 4 is equals to A of 3. That is equals to 4. Now 4 is shifted to A of 4. Now again shift one more value because still there you have to do. You have to free one more space. Now decrement the value of I by 1. So I is equals to 2. So 2, I equals to 2. 2 is greater than or equals to 2. Yes, the condition is true. Still it is true because still that position you are doing. So now A of 3 is equals to A of 2. So A of 2 gone to A of 3. Okay, now look here. A of 2 is 0. 0 goes to this position. 0 will come here. Now A of 3 is equals to 0. Again decrement the value of I by 1. Now I is equals to 1. So 1. 1 is greater than or equals to 2. Now the condition is false because look here, till only this position I need to do that operation because I am giving position as 3. It should, I am not giving position as 2. I am giving position as 3. So now my third position is empty for me. So the third position is empty. So now what I do, the third position is empty. I'll get the value I have inserted like this. I will get a new value. So 4, 0 will come here, 4 will come here, 5 will come here. So now the value I have got this as I have freed this space. Now what I have to do? I have to increment the value because now look here, n was 5. Now how many? Now the n value will become 6. N is equal to 6. So finally what I have to do? I have to increment the value of n by 1 only after inserting the item. Now look here. Now I have shifted. I have freed the space. Now this program is done. Look here. This is void insert. I am taking this program. I equals to 0 value. Enter the position for a new element. I'll enter the new position. For example, my position is position I have entered 3. Enter the item to be inserted. That is, I'll enter 10. New value is equals to 10. Now I have to insert 10 here. So now what I have to do? I have to shift the elements one after the other. I have shifted the elements. Now finally I have done with this. Now I have to include the new element. That is, I will insert a new element 10 here. Now look here, a of I equals to a of I plus 1 I have done. Now a of position minus 1. A of position minus 1, that is a of, that is position is 3 for me. 3 minus 1, that is a of 2, that is indexing. A of 2 is equals to value is 10. I'll put 10 here. After inserting the value, now how many items are there in the array? Previously n was 5, now n has become 6. So increment the value of n by 1. So n is equals to n plus 1. Okay, now n has become 1. One more extra. So this is what n equals to. Now I have to increment. Either you can write it as a size plus plus, or you can write it as n plus plus. You are here, you can write it as n plus plus. So now I have inserted a new element into an array. This is insertion operation. Okay, next one is deletion operation. So now this is how we have inserted a new element into an array. For example, I need to insert an element at the end of an array. How do we do? For example, insertion. This is insertion in the insertion in the middle. Now I need to insert a new element. For example, 0, 1, 2, 3. These are the indexing 10, 20, 30, 40 I have done. I need to insert here. So what I have to do? I have to insert a new element, that is n is equals to 4 I have done. First to insert a new element at the end, what do you have to do? Increment the value of n by 1, n plus plus, and then add a new element. A of 5 is equals to value. This is just a simple statement. Bring the increment the value of n. So n is incremented first, and then bring the positioning to a of 5. A of 5 is equals to 5, then insert a new value. This is very easy. Just increment the value of n and I and insert a new value into an array. That is, insertion of an element at the end is very, very easy. So now we will go with the next important operation, deletion operation. So what is this deletion? So I have already, I have an array. I have a array with certain elements are already there. For example, I will take the new, that is what the previous one example, 6, 2, 10, 0, 4, 5. This is the already existing element I have. I need to delete an element from the middle. From the beginning is very easy, from the end is also very easy, deletion. So I need to delete a particular item from the middle. That is known as deletion item. Look here, deletion refers to removing an existing element from an array and rearranging all the elements in an array. So to do that, I will be using a function known as del. I'll be using a function known as del. With that declaration, that is deletion of an array will become very easy. So now what I have to do? First, I have to delete an item. I will, for example, I'll delete an item over here. I'll take this as indexing 0, 1, 2, 3, 4, 5 indexing, and entirely positioning is different from indexing. This you people have to keep in your mind. This is deletion. So this is position. Position 1, 2, 3, 4, 5, 6. I have to delete an item from the position. Position is equals to 3. I have to delete. I will delete an item. Now after deleting, what do you have to do? You have to move these items which are there to the left side of an array. When insertion, we are moving them to the right side of an array, but here you have to move, first delete an item, move all the items to the left side of an array so that the space whichever you have deleted should be covered by the next elements in the array. So for that purpose, what we have to do? We have to write a for statement. So for position minus 1, I have to start from position only, right? Look here, I need to start from position. From this position I start. Position minus 1. That is indexing. This from this indexing I have to start. From this indexing, last to indexing no need to shift because already the elements are there. I no need to shift them or I know to delete them. I have deleted this. So from this position I have to start. So you have to write for statement for I equals to position minus 1. That is third position or it is indexing 2. That is 3 minus 1. So I have to start from here until what is the condition? I is less than n minus 1. Look here. I is less than n minus 1. Now n is equals to how many elements are 1, 2, 3, 4, 5, 6 elements are there. But after moving these elements, this last element will go. This will not be there. So until n minus 1, till this I have to do. N minus 1 I have to do because once you move them element, this last element will be removed. So till n minus 1 I have to do till, so I is less than n minus 1. And look here, now since you are moving backwards, coming backwards from one item, okay, n minus 1, that is you have to take this element, put here, take this, put here, take this, put here. That is I will be here, next I will go here, next I will go here. So I will be incremented by 1. So this is what you have to do, very very important thing for deletion of an item. Then finally after deleting an item, what do you have to do? As we inserted, as we have done insertion, as the thing what we have done in the insertion, same here also we have to, once after in the deletion is done, once after deletion is done, what we have to do is we have to decrement the value of n by 1. In insertion, what we have done after inserting, we will increment, finally we will increment the value of n by 1. Here we have to decrement the value of n by 1. So that is what we have to do here. So this is the program for deletion. Look here, enter the position of an element to be inserted. So I will take position is equals to deleted 3 and value of that position, that is value is equals to whatever it is there. For example, a of 3. Whatever the value it is there, I will delete. Then now a is equals to position minus 1, I less than n minus 1, I plus plus, a of I equals to a of I plus 1. This is what I have to do. Look here. Now I will delete an element from position equals to 3. So now I have to check this position minus 1. I is equals to what is position 3? 3 minus 1. So now I is equals to 2. So 2 is less than or equals to n is 6. 6 minus 1 is 5. So the condition is true. So now what you have to do is, first one you have to take the element. Value is equals to, I will delete value 10. I will delete this element. I will delete the value 10. Now the value is deleted for me. Value is deleted. Now I have to move these items from right side to the left side. That is, move these items whichever are there. Now 10 is deleted. You have to move all these items. That is, move 0 here, 4 here and 5 here. So now I is equals to 2, the positioning is 2, 2 is less than 5, yes the condition is true. A of I is equals to A of I plus 1. So A of 2 is equals to A of 3, so is equals to 0. So now this is move here, 0 will come here. Now here nothing is there. So now again increment the value of I by 1. The same procedure is repeated until you move all the elements. So I is, now I is plus plus, so I is equals to 3, 3 is less than 5, the condition is true, so bring the value of 4 here. So 4 will come here, again same thing, bring 5 here. So I will bring 5 here. So 5 is brought, finally nothing is there in the last element. So finally everything is done. Now the value of n should be decremented. So at last decrement the value of n, that is n is equals to n minus 1 or n minus minus. So that is what we are doing here. So printf the deleted item is value. Whatever the element you have deleted, you finally print it. This is what deletion operation. So these are the basic important operations which we study for a arrays. That is insertion, deletion and traps. So we will go with the searching and sorting in the next class.